Hey guys, so in this video, we're gonna discuss Leetcode 2034, the stock price problem. So in this question, we're gonna be given a stream of records of stock price, and it will contain a timestamp as well as a price for the stock. So the tricky part is a newer record would overwrite a previous record if the timestamp is the same. So we're gonna implement the four interfaces. The update interface, which we're gonna like correcting the price from the previous record at timestamp, or creating update or like creating a new record for the particular timestamp, and also the current interface, which is to get the latest price of the stock, and also to find the maximum and the minimum historical price for the stock. So basically for these kind of problems, we need to find the proper data structure we can use so that we can optimize the time and space complexity. So usually for max and the min, right? Like to find the maximum price or minimum price, in order to avoid a loop of like loop over the historical data to get to the maximum minimum, like in order to avoid the order of n complexity, we can use a heap queue so that it to get the maximum or minimum will be an order of one complexity, and to insert the data it will be order of log n, so that we can optimize on the time complexity. And to get a current timestamp, we can just use a dictionary to have a map of the timestamp to the price, and we keep track of the latest timestamp so that we can get a current price. And for the update, we can just update the dictionary and update the latest timestamp plus the min and the max heap. All right, so basically we maintain three data structures and one variable, basically like the latest time variable, and maintain the timestamp to price map, as well as a max heap and the min heap. So let's initialize the variables we need first. So first we need the latest time, and we initialize to 0. And also we need a timestamp to price dictionary, gs2 price, which is a dictionary, gs2 price. And also we need a max heap, so that we can get to the max price, max heap, the min heap. All right, so now we need to sort an algorithm to update the update price. So now we just do this, and the updated price for the current timestamp to the price, and also the latest time would be the maximum of the latest time with the current time would be the max of this and the current timestamp. And also we need to update the max heap and the min heap. Okay, so now let's import heap queue. So for the max heap, so we just heap queue dot heap push into the max heap queue with the item. So the with the item would be the negative price, because the heap queue in Python is always a min heap, so that we can have the price as negative, so that we can always have the maximum price at the top of the queue, and also the timestamp. And we're gonna do the same for the min heap. Min heap will be the positive price, so that we can get the minimum price. All right, so now we need to sort out to get a current price. The current price would be timestamp to, we just simply return the current time. Yeah, so this will be the order of one time complexity. And for the maximum price, So we just so this will be tricky part because the we don't know if the price is being overridden by a later record or not, right? So we can just keep pop. So let's say like price and the timestamp would be heap pop heap pop the self max. So just like this record may be an like outdated record because like we may have a later record which will overwrite the price for this current timestamp. So what we can do is like we can just compare this. So this dictionary TS2 price will always keep the correct price for the timestamp. So if the price doesn't match to the correct price, then we know like this is an like invalid data, so we can just like ignore that. So what we can do is like we can keep popping from there. So while the negative price doesn't equal to the self of the timestamp, so while it doesn't match, we just keep popping from there. Actually, we shouldn't pop because if we pop, we're gonna lose that in the max heap. So we just for the initial one we just do this. Yeah, so we do the heap pop and then do this. Yeah, my bad, sorry. So we shouldn't pop in the initially because if it's a valid price, then we are popping it out. We lose the track in the max heap. So we shouldn't delete valid data. So like we just pick the data and check if it's valid or not. If it's invalid, we pop it out and then pick again until we reach the valid one, right? And then in the end, we just return the proper price. All right, and we're gonna do the same for the max min heap. So it would be the same. Just replace the max heap with the min heap. All right, and let's see how it goes. Yep. Yep, it works fine. And yeah, so this is the end of the video, and I'll see you guys in the next one.